So it's a Antti Nuosjoki from the ALA studio in Helsinki, architect Hadi Teherani, and Professor Thomas Auer from the Technical University of Munich. We begin with Antti Nuosjoki, representing the Helsinki-based ALA Architect Studio. ALA Architect specializing in public and cultural building, unique renovation projects, station design and master planning. Their Helsinki-based firm was founded in 2005 by four young architects, and Antti Nuosjoki was one of the founder partners. And they have designed and built many interesting buildings, such as the Takama Event Center, metro stations, and the Helsinki Central Library, OODI. And they are also working on renovations and extensions of modernist buildings, such as the Aalto University building designed by Reilly and Nerima Petia. And I'm pleased that we are able to host the ALA team at our EM studio in Warsaw, something like 10 years ago. Antti Nuosjoki, floor is yours.
Thank you, and thanks for the invitation. So I'm gonna, in 15 minutes, present the library that got the prize in this event. So it's not a brand new building. It opened in 2019, but I think that's also makes it a little bit interesting to actually look a little bit back to it now, and also then see how it's doing now. So some of the photos are quite recent. It's a library which is part of the Helsinki City Library Network. This is Helsinki on a beautiful winter day. We still sometimes get snow, but it's not a typical winter phenomena for us anymore, sadly, for reasons we all know. And you can kind of see the library even from this kind of very elevated view. It kind of sits at the kind of southern tip of the central park of Helsinki, and the Helsinki Central Park is not a square like in New York, but rather it's this kind of green finger that extends all the way to Lapland, like Alvar Aalto used to say, and it's also kind of true. This is the way the kind of city blends with the endless forests that are our nation. So the kind of timber-clad facade is almost like visible, or is visible if you know where to look, even here. The building is one of it's part of a network of 35 libraries in Helsinki, and it's the latest one, and it's the most publicly visited one. We got 3 million unique visitors 3 million visitors last year, which is a staggering number for a city of 700,000 people, and for a library as well. Of course, it's a completely free and very open building, but it also means that it's a very kind of attractive and inviting building, which were the kind of course, key qualities that the city wanted when the competition started. Important thing to understand when we go deeper into the building is that it's part of a network. It's not a system in itself. This building has about 100,000 books, which is a small part of about the entire collection, which is about 3 million borrowable books. So the only way to browse the actual collection is, of course, online or with a device, and then the kind of part of the collection floats around in the network of 35 buildings. It's not fixed per building, but they move around, and then the titles that are rarely borrowed, they are in a storage facility somewhere. But anybody can borrow any of the 3 million titles, and then it will be in a couple of days delivered to any of the 35 branches which you can choose. So it's not a kind of question of that the more books, the better. There is a huge amount, like almost endless amount of books, but they are distributed in a smart way around the city and also in then like non-expensive locations for the kind of archive ones. So this is not an archive, this is really like an interface for the library network. The program consisted of about 15,000 square meters, which we realized that according to the zoning, we can fit on 3 floors, and 1/3 of the program was this kind of so-called solid space, what we all know what that means, we are architects, and students here. So basically rooms with specific functions, and about 2/3 was like this open space defined more by furniture and this kind of non-permanent things. So pretty quickly we realized that we can actually place the kind of solid part as a kind of thick middle floor, and then start manipulating the shape of the thick middle floor. So then we have an open space underneath it, open space on top of it, and then this interestingly shaped solid that basically defines the building. When we wrap it in timber, it becomes legible and clear that, okay, the rooms, the specific functions are, and also most of the building technology, ventilation rooms, heating systems, data centers, things like this are inside the timber volume, and then underneath the timber volume, we can create this inviting extension of the public spaces around. The building is kind of this arching bridge over this, or the timber part is this arching bridge over the open ground floor space, and the ground floor space really tries to become this extension of these public plazas and streets outside around it. Our climate is pretty harsh. Winters are long and dark and cold. So to kind of actually build these indoor public plazas is something that we are striving to do. It's a kind of, we have of course as a wealthy nation moved well past the kind of primary trying to just survive through winter, which was still an issue like 100 years ago. Now we try to survive the winter without losing our minds, and doing buildings like this and really trying to generate some kind of social cohesion and sense of community, social activity is extremely important. It's not like an extra. For us, it's something that we more and more depend on for sure. So you can see how the kind of ground floor, really the plaza is empty because it's fucking cold, but then if you go inside, the kind of plaza life exists in there. So eventually we'll find our way inside this timber piece. So you can see, here you can see the kind of, from the inside, the ground floor, extension of the plaza, then the middle floor, which contains structure, rooms, ventilation plants, ducts, and then on top of the solid, the timber floored open landscape is then the third floor. So let's look at the ground floor first. We can go inside. So really, the kind of, see, sometimes it's quite empty, like any plaza. Sometimes it's really busy. Sometimes it's just people walking through, but then there are pop-up events. There are different exhibitions. Of course, the kind of that's where the librarians first time meet the visitors. But then also we people just walk through the building, just see what's new, and then so it's not. They can kind of include the kind of ground floor experience of the building in their daily routes. There's high emphasis on making this slightly complex building easy to navigate for everybody, and of course then we need to generate interesting and exciting ways to get up. So we didn't have any, as you saw in the diagram, we didn't have any footprint in the 3-level solution to do an actual tall atrium, and we really didn't want to do 4 floors because then we would have 2 middle floors and the concept would be completely different. So with 3 levels, occupying almost the entire footprint, we came up with like that the elevators are there, but the primary ways to go up is this double helix Leonardo da Vinci style staircase, which is quite exciting, and it's a kind of hanging steel structure which hangs from the bridge structure. So the structural engineers had something to actually work on in this project. There are elevators, of course, and then there are escalators going up as well. So we really wanted to also include escalators to make sure that the upper levels get easy kind of public flows, and in a way utilize this means from commercial architecture to make this non-commercial building very, very kind of well used and inviting. There's this multi-purpose small auditorium in the ground floor as well, which has this openable wall that sometimes is open to the foyer and sometimes closed. It's not for professional performances, but more like for like different club events like this. This is some church event for seniors. And then there's a National Film Archive cinema also in the ground floor. And then the main toilet is in the basement. So of course buildings like this, they are next to a big public plaza with a lot of events and festivals, at least in the summertime. The toilet functionality is quite important, so we worked a lot on to kind of place the main toilet actually in the basement, so you kind of have to find it. You can also see that it's a totally gender neutral space. We worked a lot on how to make this kind of basement toilet feel safe and feel like something that's pleasant to use. So for us, non-typical luxury materials, this Estonian marble type of beautiful soapstone. And then really the kind of idea that the whole family or the whole community enter this one open library-like space, and then the cubicles all are kind of visible there, so there's nobody can be around the corner to kind of ambush you because there is not that type of situation. And then from the light inside, you can see what the beautiful shoes were. And the partitions are these heavy walls that go all the way to the floor, so there's no, you can't look over or under it. That once you're behind the glass door, you're kind of in a safe space, but also like the translucency brings like a certain amount of politeness to the proceedings. So we didn't want to make it look like a prison, but also make it like a pleasant functional experience, and I think that worked out really well. Of course, in a building with millions of users, all kinds of things happen, and but this has. There has been this kind of very positive response from the citizens and from the visitors as well to many of the surprising things in this building, and people have treated it with a lot of respect. Then if we go up from the ground floor, we go inside the structure. So the structure is these two steel arches that are supporting this side cantilevering steel structure, so quite an elaborate thing. And one of the reasons for this, maybe the main reason, was that we really wanted this kind of columnless open ground floor space, and also to generate this structural drama between the three levels to make them permanently different. So this is of course something you can't really change. Also because the bridge has some vertical movement, so you can't even put columns underneath it anymore, that same vertical movement that made the beautiful bridge in the Riva presentation to lower down a little bit, so the bus maybe had some. It's a pretty cool story. Same thing actually happened here, so that when the bridge was built and then they suspended the huge double staircase there, the whole thing moved down, I think 5 centimeters, but we had no bus clearance issues. We just had to remodel the entire timber facade, but that we got paid for that, so that was fine. There's a lot of structure, a lot of ventilation plants and ducts and so on. So it's kind of permanently non-open space. So it's actually very comfortable to divide. Here's the escalator. Very comfortable to divide this with walls. So when you start with this, it's not like a completely open space, but rather this kind of on the other side, kind of the other side of architecture almost. If you remember the Rem Koolhaas Biennale argument and this big model that how small part of the volume is actually the kind of public architectural space, and then there's this mechanical space that's almost more. This is almost a little bit like playing with the aesthetic wise at least, and also partially functionally, that allow the people to occupy also in a way some of the duct space. You could think of this floor almost like a huge installation floor. Certainly the aesthetics are like that, and there's no cladding to the ducts, which of course provide air also up and down from this level. You can see the structure. The secondary steel structure holding up the cantilever clad with timber to make it more touchable and friendly, but it's obviously a steel structure, as you can see from here. And then there are these steps that are the other side of the facade curve. The facade kind of eats into the floor, so we then just covered it with steps to allow for people to sit on them. This kind of completely form, not really following function, but something completely different. But then people started to find these places, and actually then this has become like a very popular, interesting space. There's a little bit of daylight in some parts of the floor, but most of it is this kind of very inward-looking place, which is great for this kind of Fab Lab urban workshop type of technologies that are very popular here. Great for, of course, gaming, for people of all ages, great for like working with screens, and then just for hanging out in a kind of social setting that's not looking through a gigantic glass wall, but rather kind of this kind of comfortable inward-looking space. Feels a little bit like an attic of like a traditional Scandinavian house. We have, of course, 3D printers, and this is a great place for the librarians to bring all kinds of experimental technologies. You can make the wiring visible. You don't have to make anything minimalistic or ask the architect that is this designed for the cabinet okay. You can just bring the printers, and there's an installation floor all over you, so you can get data and electricity anywhere you want. Really having this workshop aesthetic. If the ground floor is this kind of forum meeting place with the auditoriums, space for big groups, space for pop-up events. This is then the floor for making things, for doing your homework, for gaming locally with your friends. This kind of intersection between online and on local presence. And also the quiet rooms. Of course, the walls enable also quietness. So in these open spaces, there's always some kind of background noise. The escalator makes a bit of noise. The espresso machine, the international architects who visitors complaining about the details make a little bit of noise always. So to actually study in quiet place, you have to go to the middle floor and like to these acoustically separated rooms. There's people doing all kinds of things in this building, it's not only for leisure activities, it's completely okay to organize business meetings. There are these small catalog of meeting rooms and workrooms in the middle floor, which you can just book from the same online system where you book the books. You can borrow the spaces as well. They are free of charge, and you can have company presentations and board meetings as well. Finland is kind of like a country of citizens associations, so most of the meetings, I guess, are more about the kind of chess association arguing about their change of rules, or like who's the cashier this year, or these kind of important things in civil society. And then having gone like into the ground floor and then through the timber-clad middle floor, we then arrive to the top floor. I prefer to do it with an escalator, but the staircase is fine as well. So now, being on top of the kind of, in a way, the machine with the oak floor, you can see in the winter that the cantilever which covers part of the outdoor plaza is of course then sometimes covered with snow. We have these low bookshelves, or 1,500 millimeter tall bookshelves, so like most adult persons can actually see over them, which is like something that the librarians insisted. So they don't want this to be like maximum capacity archive building, but rather make the books that are here easily browsable and inviting, and they try to always showcase the interesting part of the collection here for people who not everybody kind of finds their book online. Most people nowadays do, but it's still possible, of course, to go there and browse. And so the shelves are laid out so that the browsing is inviting and it's clear. And then, yeah, it's a great way to find books that are maybe otherwise something that you didn't even know that existed. You can tell, like maybe you saw in the diagrams as well, that we also lifted the ends of the volume up to hide escape staircases and toilets in the top floor. So we really tried to avoid building walls here. We of course have the elevator cores, but even they don't go all the way to the ceiling here. The frame is stabilized separately. And then it's a continuous glass wall all around this 4,500 square meter space, which then means that it has these kind of very strong landscape-like qualities, especially with the undulating roof. Roof is undulating also to highlight the fact that this is the top. There's no levels above. You've reached the highest level of this library, that you can kind of, in a way, to make things like these are not only for the orientation, but really to emphasize that there's the ground floor, the middle, and then the top. So to kind of really celebrate the top by shaping the ceiling. But that also generates this effect of the space constantly changing a little bit, because of the curves, because of the changing print pattern in the glass facade, because of the furniture. Any small movement you make in the space, you are in a little bit of different space. The acoustics change, the view, the light condition, the mood changes a little bit. So there is this thinking that since there's about 500 chairs on this level, you can try to find like a spot that you feel pleasant in for your current mood, or like try to experience different moods there. That's not something that people really do consciously, but most people find the kind of top level of this building, this level, very comforting and kind of beautiful. And I think it's because the kind of curve also makes so that you don't really see the edges, or the kind of shape of the edge of the roof or ceiling kind of changes with your movement. So it's a little bit the similar experience as being on a boat in a sea, that the kind of it's constant and it's calm, but it's also a little bit changing all the time, or maybe walking through Finnish forest as well. So there's this kind of calm, comforting, and in a way beautiful experience. That then also has to do with literature actually, because like buildings, like libraries like this, of course, most of the actual like data and information we have is like purely from online sources, and more from like these artificial intelligence gathering machines. Books are more and more becoming the kind of the medium for art, the kind of, and that's of course also being like digitalized, but they're kind of physical book that used to be so that in a typical library, let's say 50 years ago, maybe only 10% of the actual book volumes were literature and like fiction. And now it's much more than half in a library like this is actually fiction. So it's also it's a building for the authors, for the art of writing and for the thinking behind that. And I read a lot, and one of my idols in literature word is the Polish genius Olga Tokarczuk. Sorry for the pronunciation, Olga. But and so her magical books kind of are something that I think about when I kind of visit the library now. That she's spoken a lot about this kind of in a way, generating these mysteries and something that, in a way, generating doubt in the reader's mind is something that she said when she visited Helsinki, that it's not immediately obviously clear what happens in the narrative, that people have to kind of work themselves and work their own psyche into the narrative. I'm not saying that this library tries to generate doubt, but it maybe tries to generate an environment which is not like a crystal clear, like mathematical, modular, technical answer to a specific like technical question, but it tries to go beyond that in a way that great literature also goes beyond like conveying just information and conveying just ideas, that they kind of in a way manipulate, certainly Olga's books manipulate my mind pretty heavily, and this I feel, I don't know what she thinks, but I feel that this type of library space resonates with that kind of very high-end literature, which also then has like a more serious side to it. I mean, this building was opened in 2019 and the world was quite different then. Then this was before the pandemic and certainly before the war. So in a way, maybe this was one of the high points of Helsinki life. We had like a lot of optimism that partially is not there anymore. So I think when we look at this now, I honestly think also that this maybe is a reminder of something. Sorry. A reminder that, of something that we really need to maybe defend quite heavily in the upcoming years. And also, you know, also with the pandemic, I feel that we lost quite a bit of things from Helsinki that are still quite slowly coming back. So the library has come back. So I think the library is something that really, you know, maybe reminded people about that, okay, we have this city, we should maybe use it for something. So now I think what I mean by defending these things is also then defending some of the values that this building embodies, this kind of openness, this kind of acceptance of different people, and this kind of, I think, very historically deep Finnish idea that, okay, you ended up living in this country, that allows certain amount of personal freedoms, that we are not gonna dictate what you do and with who you do things in your bedroom, for example. Finland has always been surprisingly liberal country in that sense, and I think the library system has had like a significant like historical role in distributing, for example, information about how society develops, about the freedom of like increasing women's rights, increasing gay rights, things like this, things that are under like tremendous challenges at the moment. And these challenges are also a little bit coming to Finland. So maybe the kind of role of this building facing the Finnish House of the Parliament right there, in a way the kind of the informed urban citizen and the international visitors are kind of looking eye to this relatively strange 1920s parliament building. And the kind of this architecture against that architecture is quite interesting as well. And the kind of contemporary architecture is moving to a kind of very strict direction and very austere direction. Once again, it has done that several times, I think, even in my lifetime. So the kind of this relatively complex and rich contemporary architecture is it's a very permanent building, and it's not a monument for something of the past, but it's kind of slowly maybe becoming this in a way reminder of our happier times and something that hopefully we work hard together to keep hold of these values and to defend them and you know, hopefully soonish we can then start moving forward with more positive thoughts instead of just spending all our money on defense budgets and things like this that are absolutely necessary at the moment, but not really bringing like a very positive vision to our future. So the library is there as a reminder of a positive times. That's what I'm also trying to say. The balcony is fun in the summer. The kind of and it also has this symbolic dimensions that when the winter comes, then the balcony is closed, and then you can only look at the closed balcony from the inside and wait, hope for the summer to someday arrive. Summers in Finland are, of course, beautiful because the sun doesn't really set that much, so then we have light from pretty surprising directions, especially to the top floor with the continuous glass floor. You can experience some pretty wild phenomena. And yeah, hang out in the balcony, look at the other maybe more monumental and more conservative buildings. And I don't think it's a it's a surprise that this is the most popular building in the area. So that's where we are with the library and some other thoughts. And thank you for the prize, and looking forward to the rest of the day.
Thank you very much. The next key speaker is Hadi Teherani, well-known German architect of Iranian descent. And Teherani is not only a practicing architect. He's working also on applied art, furniture, lighting, rugs, wallpapers, bicycles, and much more. His work has received numerous awards, and his most important projects include Crane House, and an ensemble of 2 office buildings and residential building in Cologne, Dancing Towers in Hamburg, and the Dockland office building also in Hamburg. Please welcome Hadi Teherani. Thank you.
So, thank you. I will start soon because I have too many pictures, and how does this work? So this is so we are designing in every scale, everything. So I show you some picture. When I started in 1988 in Cologne. I had my architecture office there, and I made fashion, so you understand why I'm so pinky today. No, this the other way around. So this is what I designed in 1988. We also take fabrics and make some color on them, but the colors didn't change until now. It's nearly 40 years ago. We are working for a lot of brands in the product design, and there are some of the brands. So from the first day, I thought about everything. The holistic approach is what is in my DNA. So I think when I have to start in everything, not only the architecture, I think about sustainability, I think about the brand, I think about all the things. And this is the first building I built in Germany. It was in 1990. It was a showroom for only cars which has a logo, which has a wing and the logo, like Aston Martin, Rolls-Royce, and all the building is designed with wings. And this is the first glass construction with the points in Germany. So, and also the construction of the inside is like this. Or the next building is for Tobias Grau. He is a designer for lighting. on those times we designed this. This is our first building with wood construction, and the glass is controlled with the sunlight. It's turning and opening, and this is also from 1995. And we have the first photovoltaic elements in this in the facade. So sustainability is something for me that is something which is very normal. We all have to do it. What happens? So, and you can integrate the voltaic elements also in the architecture, like this. These are pictures from today in the same building. So I make a little bit fast. And so the next was the train station in Frankfurt. When you at the airport, at the train station, this is the first warm station in Germany. So under the pedestrians, we have 400 meters filled with water to control this, and the trains will come. Hello. Yeah. And the design, the airport said when you come out of the train, you have to have the feeling that you are under the plane. So there's a 60-meter wide, and it's you cannot feel the heaviness of the construction, because on top there's a building with 8 or 9 stories. And how we did it, the columns, they are looking like telescopes, like antennas, so it makes it very light. Yeah. So another building in Hamburg, I had my office here for 10 years. It's a house-and-house system, so it's a low-tech building. We control everything only by nature. We have 6 times in 1 hour changing all the air or the bad air to the new without any electricity, only with nature. It's working like this. We have piazzas on the levels, and here I started to think about how we work in future in the office building. So we started to make product design. That was our office. It was the next building. This is the Sheikh Zayed University in Abu Dhabi. We had only 26 months from the first sketch to the opening for 250,000 square meter. We had 7,500 workers. When I was thinking to draw, they built it already. So yeah. It's a huge roof, more than 400 meter long, and there's a library. We also make the interior design and also some chairs. When I started to make product design for a chair, it was in the time 2004. I love the Eames chair, and but they produced this chair. It's for functional and ergonomic, so you can sit on it good. And but I thought it looks like if you have it from an insurance company or something. Yeah? So I said, we have to make a chair where I can show both the design and the function. And then we designed this chair. It's now also more than 20 years old, but it's still one of the classic chairs. And this is my dog. This was my dog. And so in this chair you find in James Bond film and most of the Hollywood films you find this chair in Star Trek. I didn't come to Hollywood, but my chair. This is a chair for Walter Knoll. At the G20 in Hamburg, all the guys sit on this chair, from Trump to Merkel and all this. And I thought maybe the good design had an influence to the politicians, but it's not like this. Here we designed for Tonet. And this was also, we designed a working place which you can close and move somewhere where you want, and you have everything what you need in this box. The lighting for uplights, lighting for the table, electric table that goes up and down. And here another thing, Foyer came to me and said, Adi, do you know, we don't sell our tiles so good. What do you think? I said, yes, they are so ugly you cannot sell them. No? And they say, can you help? I said, yes, but it's not only a design strategy you have to. Then I take the tiles and cut it in pieces like this. And so you had thousands of possibility to make your carpet, or like this. And then I learned product design is not so bad, because I get 10 years royalties every year, 150,000 euro, only for cutting the space. So this is another building in Hamburg in the river in front of my office. They said you cannot build there because you take the views. I said, no, I give you better views. And they said, you're arrogant. Yes, I said, no, I really do it. And then we put a public stair on the office building, and so this works. Another building in Cologne. This is a Rheinhafen in Cologne. When I made the competition, this is wrong there. It was in 1991, and it takes 15 years that the city said you can do it. And as an architect, you have to get old and be fresh. And from the first sketch to the building was 20 years in the end. So we built, because the harbor went out of this place, and give this place back to the city for living and culture and working. So and and there was not enough space, so I built in the air, like a crane. And this crane is showing a little bit what happened there before. And now I know why they take 15 years, because they have the dome. And the dome, nothing has to make concurrent to the dome. But now they present their city with my crane houses. And the top there is living the football player Podolski from Poland. You know him. He is there in the penthouse. It's one residential and 2 office buildings. So we have a big cantilever, and this is when you look under to the Rhine. This is in Hamburg, the dancing towers. So I always take all my ideas from the site. When I see a site, I always say the design is already there, you only have to catch it. So St. Pauli is the amusement area since hundreds of years in Hamburg. Maybe you know Hamburg. Take the mood of the area. Working? Nice, working, yeah. So this is maybe covers for the. Yeah. So this is what I say. I work in every scale. The cufflinks are only 1.5 centimeter, and long comes from the pen. So we take the pen and then we. Aluminium facade. Working. So it's finished 1 years ago in Hamburg. I had to work with brick, and always looking, because I'm known as the glass architect in Hamburg, and they say, "Oh, let me see what you will do with brick." Yeah? And so we take the brick, but in another way. This is brick from Denmark, inside that I have my own world. It's not too wide, it's in Hamburg. Thank you. So I get a little bit quicker. I don't know what will come up. Big light inside and all white, and outside is the brick. So I think here's a film. This is the city of Hamburg. clinics. Now with small scale. For heavy we did the door handles, and it's interesting when you design a company for a brand which is existing for a long time. You have to go to the DNA of them to learn everything, and that you can design a product which is coming from them. So. So used a lot in island Sylt. I don't know if you know the island in the North Sea. Real thatch, Redach. Smallest house for a bird family. They go only in production. They test it half a year. When a bird comes, then they will produce it. And after 3 weeks, a bird was there. And I asked my staff, who put the bird there? Yeah. And so we had there's a duplex designed tiles for garage. Old television Röhren, I don't know what you call. In Milan last year. And now we jump over to Iran. There's where I'm coming from. This is an exhibition hall in Yazd. So they built most of the buildings in the ground because it's very hot in the summer, and in the ground it's much cooler. So also we go down and hide it from the sun. Or this is a villa in Tehran. In Tehran we have an area for luxury residential. It's called Lavasan or Tehran Angeles. Yeah. And this is a garden for trees. You go down and you Tehran is in the mountains, 15 to 1800 meters high, and the biggest mountain is 5,600 meters. This is a normal residential we built in Tehran. Water, you go on the stone. The door is 5.50 meters high for the apartment. Every house which we build, we have a big lobby like in the hotel. You have swimming pools, every facilities. and only the lobby for 12 apartments. Parking is pool. Maybe you don't know what's also happening in Tehran. It's a hotspot of design, film, architecture, but nobody knows it here because we know only the bad things. There's the gym, kitchen, and this is another project we built in Tehran. And we built some of the apartment buildings. They used to have a big space. We built one building, the smallest units of an apartment is 500 square meters. The biggest 2,000. And it's a little bit war there, but even in the war, we get weekly new contracts. The people are very crazy there. And they are now sanctioned since 40 years. Every product what you see, they build their own in Iran. They are looking like all the Italian brands, like B&B, Italia or something, but all produced in Tehran. There's another building it's under construction now in Tehran. And bricks, and we of Iranian culture and put it in the fabrics. Is corn. You should not eat it, but you can. Don't to the place where you need it, printer there, and you can print it. Austria. Underground, and they said we need this panorama sauna and yoga place and something to swim. I said, no problem. So I was hotter, the blue got in cup, and recreation area. And we had to work a lot with parametric design because it's curved and degrees hot pool, and so our team. This was the opening with some celebrities. Sylvie, you know her? Yeah. think this is the, oh no, here's another one. This is in northern Germany. We want to build a lakeside resort. And there are moraines, it's a very nice area. So we bring it out of the landscape and you can go 500 meters only on the roof. Yeah. I think this is the end. Now I'm doing, because architecture is now, Germany is going down a little bit. So I do now
Thank you very much. And last but not least, very eminent Professor Auer has participated in numerous design projects within Trans-Solar Energy and Technique, including the Renew Manitoba Hydro Place building. And he has taught at numerous renewed universities, including Yale and École Spéciale d'Architecture in Paris. And in 2014, Thomas Auer was appointed professor and chair for building technology and climate responsive design at the Technical University of Munich. So, Thomas Auer, the floor is yours.
Thank you very much. It's a great pleasure to be here in this amazing building. I just thought, like, the system here is not doing a good job. Isn't it? It would be great to open just a window. But that's exactly what I would want to talk about in this, in my lecture, talking about the complexity of buildings and if we need a new simplicity. But okay, this way. So we all, I hope we all believe that there is something like global warming. I always say, like, people who question global warming, they can also question gravity. I mean, that's sufficiently proven, and nobody should doubt it. So the question is, what is our responsibility and what is our role? And we know that the building sector is contributing significantly. And what does it mean for us? I mean, there are all these numbers, and I don't need to repeat all of them, but we think about something like 40%. CO2 emissions worldwide is what the building sector is contributing. And in addition, there is a big need particularly for affordable housing all over the world. So how do we bring those things together? That's not an answer. So it doesn't help if we apply gadgets onto something that is stupid to begin with. Yeah. I always thought I should replace this now against a Tesla space truck. Just to be on time. Okay, so but what is the answer and what do we contribute? This was not a project where we saved energy. The opposite was actually the case. In 2010, we got invited, Transolar, to do an installation, to provide an installation at the Architecture Biennale when Sechima was curating. And so our idea was that we produce a cloud, an indoor cloud, because for us, we call our profession climate engineering. And the cloud for us was not a piece of art. It was a showcase for climate engineering. We manipulate climate to the extent that a cloud becomes visible. That was the idea. And the idea of a cloud is generally pretty simple. You need a layer which is saturated, where you have 100% humidity. And when it's 100% humidity, you can spray in water, and then the water cannot evaporate, and the cloud starts to appear. And everything else is like density. Warm, humid air is lighter than cold air, so it goes up. So we had a layer of cold air at the bottom, cold and dry air, and then a layer of humid air, which is ideally saturated so that we can spray in water to have a cloud. And then another layer on top, which is hot and dry, so that the cloud doesn't touch the ceiling, and because then we would get condensation and the cloud would disappear. So it's just play with density. It sounds very simple. The physics is very simple, but it actually took us a couple of months until we had these layers stable in Venice, in the Biennale, in the Arsenale. And then Tetsuo Kondo, architect from Japan, he designed the space, he designed the ramp where people could walk through the cloud and experience the different temperature zones from above and below. This was an amazing project for us. This is not what we usually do. To be honest, usually we try to avoid clouds in buildings. But it was for us very interesting to show to what extent we can really manipulate climate, and to what extent we can provide comfort for people and not for spaces. That's the entire idea behind it. But if we go back in history, in architecture history, and we had a seminar last semester with Jeanette Cour at the TUM, which we called Breathe, and it became very obvious for me that architecture history, vernacular architecture, was always about breathing architecture. And also the beginning of modernism was about breathing architecture. It was like post-war. It was the 50s and the 60s when we started to believe that we should enclose buildings and use mechanical systems to provide comfort. So it's very recent, this movement. And if we look back, this is the Flatiron building built early 20th century. And what you see is that every window is operable for natural ventilation. Every window has shading devices. So I don't want to say it was always great, the comfort in this building, but architects and engineers knew exactly what to do to make the best out of the situation. And somehow we totally forgot this because of this. Then there was the invention of the air conditioning. And it was like invented in the 20s already by Carrier. By the way, to be precise, mechanical cooling was invented by Linde in Germany, in Bavaria, something like 1880. And guess what was the reason? Any idea? Beer. Yeah, I heard it. I was about brewing beer in summer. That was the reason. I mean, it's Bavaria. So it took Carrier another 30, 40 years to recognize that this technology can also be used for comfort. And then in the beginning, like you see, they wanted to make a lifestyle product. It's like the wealthy family, it's the American dream. They sit in the middle of nowhere, they have their air conditioner, and they have comfort, whereas the poor guy, he needs to provide the newspaper in the heat. So it was like a lifestyle product, and it was not successful. That was quite interesting, because there were two opinions about air conditioning at the time. The first one was that air conditioning is making people sick. and which is to an extent true, but that's something we would go deep into the physics and the biology of the body to explain. But the second one was that people said, we don't need it, we're strong enough. Only pansies have an air conditioner. So the reputation of air conditioning was really bad, and it was actually science who made the air conditioning, let's say, successful. It was Foyer in the 70s who did his studies, who became like international code in ASHRAE, but also in Europe, who came up with a comfort window for people, which is between 20 and 26. That was a result of the studies of Foyer in Denmark in the 70s, and then suddenly people came up with the correlation that comfort is also healthy. Something we want to question and discuss at the end of this presentation. However, that was the mindset, and suddenly air conditioning became successful through ASHRAE, through Foyer, through science. So something we have to be aware in science, if we're now questioning air conditioning, and we come to this in a minute, that we have to be careful with the messages. We can also easily become an enabler for technologies that the industry just want to sell. And to make this, let's say, to prove what I just mentioned, just talking about here how architecture then developed after the invention of air conditioning. Also modernism developed, like a Seagram building would not have been possible without air conditioning. It's also suddenly architects like Mies van der Rohe, like Corbusier, saw the possibility with this international style architecture that they can really design the same architecture all over the world, independent of local climate conditions, independent of local culture and heritage, etc., etc. That was driven by the invention of air conditioning, and suddenly we see buildings like this. This is Canary Wharf in London, the business district. And the reason why I show this is because something like 2 years ago, I heard someone from Arab engineers from London giving a talk about this area because they did a study because of taxonomy, of EU taxonomy, because of ESG, all these banks need to provide a sustainability reporting. And all of a sudden, they recognized how much energy those buildings use. That was the first moment, aha moment for them. And since then, all of Canary Wharf, built in the 90s, is considered a case for energy renovation, for energy upgrade. And they have no idea, they have no solution. They were discussing to invest in carbon capturing on Iceland to compensate for the energy consumption of these buildings. These buildings do not have any operable window. They do not have any external shading. It's just stupid glass facades and use a huge amount of air conditioning, possible only because of the invention of air conditioning. That was the only reason why we see these buildings. So, and then if we look deeper into air conditioning, this is a study provided by the International Energy Agency, and this is their expectation to what extent the amount of air conditioner, the installation of air conditioner will increase over the next decade. And the assumption is that by 2050, but generally the amount of air conditioners installed will go up exponentially. And the power consumption for air conditioning in 2050 will be as much as the entire energy consumption of India and China today. That's what we expect. And there was just recently, the International Energy Agency published that in 2024, worldwide, the energy consumption was increased again by 2%. Doesn't sound much, but it was only 1 year, and we want to go down. It's increased again by 2%. And half of it can be dedicated to air conditioning only. So we really need to discuss air conditioning and what it means. And that was the reason why when we got invited this year for doing an installation at the Biennale, and Colorati asked us if we to provide an installation that makes climate change tangible, experiential for people when they enter the Arsenale. We said we have to combine this with a message. And the message has to be around air conditioning. So we installed all of these air conditioners, and this entrance hall where we collaborated with a big team is actually indicating the outdoor conditions of Venice in 2100. On a normal hot day, the predicted climate conditions of Venice on a normal hot day will be 42 degrees. And that's what we displayed here, experiencing 42 degrees as you walk through the space. This is an outdoor space, and then you were walking into the next hall, and then we had, like I have to say, only 12 of these 100 air conditioners we put there were in operation. All others were only making noise. So we bought on eBay broken air conditioners. So if you need a broken air conditioner, in November we have some of them left over on stock. So only 12 of them are operating, but they provide the heat by air conditioning the second hall. And so as you enter the second hall from the first hall, you get this experience like you get from the heat into an air-conditioned space, and the first moment it's a relief. But if you turn around your head, you start to recognize that this is the heat that goes into the first hall. That this is usually the heat that we damp into our cities. So when we air condition our spaces, someone has to pay the price. I mean, that's basically the message. It's the city with its microclimate, it's the global climate. Like the air conditioning, a metaphor for comfort. So we have to be aware that climate change is driven by our comfort expectations. And it's not that I want to give everybody a bad conscience. I mean, I was flying here yesterday. I mean, we all have our mistakes, and but I think it's important to create some awareness for all of us so that we start to think about our behavior patterns. And so, as a matter of fact, we should not design buildings like this anymore. That's something we can conclude. But what is the model? I mean, that's what we are all discussing. And I had the pleasure, I mean, you mentioned it, working on this Manitoba Hydro building, which was very ambitious with KPMG architects from Toronto, with Manitoba Hydro as their local utility company. They had the idea that they wanted to have the most energy efficient high-rise building in North America in this very harsh climate of Winnipeg, with temperatures going down to minus 35 degrees in winter, with plus 35 degrees in summer, half the year at temperatures below 0 degrees. But what everybody told us is whenever it's cold, really cold, then it's always sunny. And this is something we found strange. And we looked into the climate data like we always do. So we always take local climate data and try to understand the climate by looking into the hourly data and analyzing those. But by the way, the best source for local climate conditions are always taxi drivers. So when I arrived the first time in January in Winnipeg, I got out of the airport and it was like freezing cold. And I was jumping on a cab and I said to the cab driver, "This is really cold here." And then he said to me, "You think it's cold? We just got a heat wave." So then you start to understand what the climate is about. But we looked into this and we figured out that on a horizontal surface, they do have more solar radiation than any location in Germany, almost as much as the city of Rome, which was very unexpected. And then we looked at how much solar exposure do we got on a vertical south facade. Because in winter you have low sun angles, and then you do get more exposure on a vertical south facade. And we figured out that we actually get more in winter than in summer. So we thought this became the driver for the design. And when I say we, I mean it's always something that we study the data and then we discuss it with the team, with the architect, with the other engineers, the mechanic engineer, structure engineer, and with the client. It was actually, the schematic design process was almost like a research project. And it took a year to go through the schematic design process for this project. We ended up with a scheme where we have almost like a twin tower with this kind of capital A letter shape. Had various reasons, we don't need to go through the details, but because of the shape of this building, we got this south-facing atria. The laser doesn't work, but you can see it. We got this south-facing buffer zone, which we then called winter garden. In the meantime, we tend to call these spaces mid-door spaces, because we believe that there should be something else than indoor and outdoor. There should be zones of transition. It's something we forgot about. In facade engineering, literally, when we talk about the facade, we talk about the line of defense. So in engineering, we have reduced the facade to a line, whereas traditionally, the facade was always a zone of transition. That's something we completely forgot. And we wanted to integrate into this building, and then we ended up with a scheme where we have an 18-story tower on a 3-story podium, and we divided the 18-story tower into 3 6-story packages, and we have those winter gardens or mid-door zones in each of the 6-story, and we supply the fresh air into the winter gardens with 10 degrees. We condition those winter gardens to only 10 degrees and let the sun heat up the air. And then we take the air from the winter gardens, distribute it by a raised floor plenum to the depth of the floor plate. We bring the exhaust air down where we have all the mechanics for the heat recovery, and then we have radiant tubing in the ceiling operated by a geothermal system with almost 300 boreholes going down 120 meters deep under this building. So that's it, and then when we don't need heat recovery, we have the solar chimney driving natural ventilation. We actually measure this building a third of the year without any mechanical system, just with natural ventilation. This is the winter garden. This is the mechanical room for ventilation for this building. There is no other space for ventilation, and under the benches you see on the right side, there are the mechanical units that provide the air at 10 degrees into the space, and then you see this water curtain at the backside. This water curtain is providing some humidification in winter, and behind the panels on the left side are the units that take the air from the winter garden, heated up by the sun, distributing it by a raised floor plenum into the depth of the floor plate. And then to the east and to the west, we do have double facades, which was very popular at the time. Bruce Coabara, the architect, he always said, like, when you give a public lecture in North America and you talk about double facades, you also double the audience. Because this was the fancy thing from Europe, double facades. And we also ended up with a double facade here. It has some reasons, can talk about the building physics, can talk about that it's just not true that in a thickness of 10 centimeters of a facade, we can mitigate between minus 30 degrees outside and plus 20 degrees inside without getting condensation on cold bridges, etc. It's just not true. I mean, this is what facade engineering makes us believe, but it's not true. And with the double facade, we could solve those issues, but particularly we could get operable windows and natural ventilation into this building, which we are very proud of. In the meantime, I believe that operable windows and natural ventilation should be a human right. We should not design any space or any building without operable windows. What does it mean? What was the result? The result was that, which was interesting, because we have only radiant heating and cooling. We cool the building to the famous 26 degrees, which is very normal in Europe, very unusual in North America or Singapore or internationally anywhere. And we have no control in this building because the system is so slow reacting, heating and cooling just connected to the slab, a 30 centimeter thick slab. So if someone comes and complains that the space is too warm in summer, it will take a day or two to change it, if you can change it at all. But the interesting thing is that compared to a traditional air conditioning systems Manitoba Hydro has in their other facilities, we had in the second year of operation already only half as many complaints for too hot or too cold. And we also have in this building 1.25 less sick days. So it's just a rumor when we always say the Americans, or North Americans, let's say, these are Canadians, they need to hear the air conditioner and they request, there is a need for the draft, they need to feel the draft. It's just not true, they just don't know better. If you give them a high comfortable system, they appreciate it, which you can see in these numbers. And the interesting thing is, if you look at money, there are 2,000 employees working in this building. These 1.25 less sick days times 2,000 employees is worth something like $2 to $3 million. The entire energy savings in this building are worth only $1 million. So you can't use economics to convince a developer in an office building for a commercial building to design a sustainable building. It just doesn't work. But I wanted to come up to the next slide, but this was the result. MNECB was the code requirement from Canada when we designed this building, and through our modeling, that's actually what we do. We do computer simulation. We predicted that we can operate this building with 88 kilowatt hours per square meter in a year. That was the result, and when we monitored the building over a period of 2 years. And so we concluded that the first year of operation, when we have a full set of data, the building used about twice as much energy compared to what we have predicted in design. So this is what we call performance gap. And this was in September 2010. And then what you see here is October 2010, November 2010, and so on, always looking backwards 1 year. And it took us 2 years to get the building to operate as designed. This is not a super fancy high-tech building. We would say compared to North American standards, it's actually a low-tech building, but it took us 2 years to get the building to operate as designed. I mean, the first moment was like a relief. We managed that it works. We got under the magic 88 kilowatt hours per square meter in a year. I mean, all of Canada and even the US, people were looking at this building. This was highly published even before it was finished. But it took us 2 years, and it was not a single problem. It was like a bucket list of 100 problems. Of 100, I just say a number. I mean, you can't. Studying this question of performance gap. And then he looked into literature and he found, for instance, this study from the Royal Institute of British Architects. And they looked into 60,000, this is online, better spaces for learning. You can look it up. They looked into 60,000 school buildings all over Europe and found that 95% of the buildings do not work as designed. So we just accepted that we pay a fortune in construction. We pay a fortune particularly for mechanical systems. We pay a fortune for building controls, and we accept that the majority of the buildings we build do not work as designed. That's the reality. And the question we ask is, how do we get out of this? What can we do? And I think there are only two possibilities. The one possibility is quality control. And I have no idea where we get the human resources. I mean, what we did here, you can't imagine how much work this is. A building like this has 10,000 data points or more. So you really dig through all the data points manually by hand to find the errors. So how do we do this with all the existing buildings? And the other possibility is to simplify. to simplify our buildings. And we really believe that the world of building design has become too complex. So we need to question, as much as we are proud of this building, as much as the owners, the client loves this building, the architect loves the building, we love the building, we have to question the building. And Manitoba Hydro particularly had the ambition that we do not design a cool building and a landmark. They had the ambition that this building is supposed to become the new role model for climate responsive design, buildings that react to the outdoor conditions. And we failed. Basically, nobody in North America, nor in Dubai, nor anywhere else in the world copied the idea of a climate responsive design, the way we envisioned it with this building, of facades that are reacting to the outdoor conditions, etc., etc. Nobody. So we have to admit it's too complicated and nobody cares. We just see, I have to say, stupid buildings. That's the majority of what we see. And so the other possibility we have is, so this is basically the summary. We have failed. The other possibility we have, can we simplify construction? And then we need to talk about embodied carbon. We always have this Olympics when we talk about building design. I always say, like, the last decades have been driven with the title "Because We Can." And I tell you, I don't want to blame anybody. We worked on tons of those buildings, and we still do at Transolar, because it's so difficult to change direction of this big ship of international building design. But anyway, this is Shop Architects, and they designed this building and labeled it as the skinniest skyscraper in the world. The skinniest, either it's the tallest timber, the skinniest, whatever. We always find a title in this Olympic game of the coolest. I don't need to go through a life cycle analysis to get an idea how much embodied carbon is necessary to make something like this happen. And I don't want to say that we need buildings with a big gesture. I mean, we saw the library in Finland, which is amazing. But it's a big gesture for the public. What is the public contribution of this building? This building is there only, maybe I don't get it, maybe I'm too stupid, but this building is only there because people can pay a fortune for this view of the central garden. That's the only reason this building is there. This building is not there to serve a real demand. Okay, so I think this is something we should discuss as a society, and we should discuss as a profession. I don't want to blame anybody. We worked on tons of similar buildings, but we need to go through this discourse. So what's the new role model? That's the question we are asking, and together with Florian Nagler, a colleague from Munich, he has an architecture firm in Munich and is a colleague at the TUM. We studied 12 school buildings in Europe, most of them in Germany, and it got published in a book, and I don't want to go through all of them. I just want to compare two buildings. On the upper left side, you see a building from 1898 from Theodor Fischer, a very famous and important influential architect at the time in Germany. And on the bottom right, you see a building designed by Florian Nagler himself together with another colleague, Hermann Kaufmann. And it was a research project, was mass timber, school building, and designed for maximum energy efficiency, state-of-the-art, maximized energy efficiency. So we did measurements in all of those buildings, and you recognize that the Theodor Fischer classroom from 1898 was bigger. It was like it has a 4-meter floor-to-ceiling height. It has 80 square meters. Today we built 50 square meters with 3-meter floor-to-ceiling height. We did measurements during occupation time over half a year during summer and winter. We looked at temperature, we looked at humidity, we looked at CO2, air quality, etc., etc. I make a long story short. This is the Theodor Fischer building in Munich. It has thick brick walls, tall space, exterior as well as interior thick brick walls. It has no movable shade, nothing. It has a reasonable fenestration ratio. At the end of the day, this building had, among all buildings without mechanical cooling, the best thermal comfort in summer. This building had, among all buildings without mechanical ventilation, the best air quality. And it had the best, most even daylight distribution with the lowest fenestration ratio because of these tall windows, bringing daylight deep into the space. So what have we lost? I mean, what did we forget over the past 120 years? And this building was in 120 years not going through a major renovation. This is the mechanical room of this building. It's a boiler room with 30 square meters. Florian Nagler built this monster under his school to provide the highest level of energy efficiency conceivable. They have a so-called variable volume system where you have in every classroom occupancy sensor and CO2 sensor and providing the ideal amount of fresh air into every space so that you do not waste any energy. The research institute from Munich was going through the monitoring. It took them 3 years to get this monster to operate as designed. And none of us believes that with all these movable parts you need in these systems like this, with all these sensors which need to be calibrated every couple of years, who is doing this? Like the facility manager in a school, like that's not a trained engineer usually. This guy is sitting in a cockpit. So, I mean, we immediately recognize that it doesn't take 120 years before this system fails. It's not even taking 20 years. It's probably already in 10 years. Who is looking for all these motors, little motors that are operating these flaps, if those operate properly? Nobody does. I mean, this is why we measure these performance gaps. And so this cannot be the future. It's just simply impossible. I don't want to talk about the aesthetics. I mean, we love these buildings, but I don't want to say we have to go aesthetically back to the, let's say, early 20th century. But we have to go back to the idea that we operate, that we provide comfort with architecture, mainly, and systems are only supplemental to support during the extremes. I mean, that's an idea which has to go back into architectural design. And then after this project, then Florian Nagler came and said, let's start a research cluster, which we call Einfach bauen, build simple. How can we build simple? So it's not about only mechanical system, it's also about all these layerings we have in our buildings, all the plasterboards we put everywhere, because on everything we don't want to see, can we get rid of everything? Can we get rid of those layers, and what does it mean? And so these were studies done by Florian Nagler and his people saying, like, we looked into the three typical construction material in housing, which is concrete, and then in Germany, timber and brick. So those are the three typical materials. And we said, like, what if we use insulating concrete? Like today, we have this load-bearing concrete wall on which we glue insulation, and then we have this shading device, and where we put the shading device, we already have a cold bridge. If we want to solve the cold bridge, we take a vacuum panel where we don't know how long this vacuum is going to last. And then we have, very typically in Germany, I'm not sure if you do it in Poland as well, we have this floating screed, floating concrete. We pretend that we do this because of the acoustics, so that we do not get like acoustical transmission to the floor below when people walk on the floor. As a matter of fact, we do this also to run all the installations in this layer. So we have all the heating, piping, all the electrical wiring. We put below this concrete layer, even though we know that the expected lifetime is potentially very short. And then when it doesn't work anymore, when we need new piping or new wiring, we rip out this 5 centimeter slab we bring in the new wiring and pour concrete on top of it again. So that's why we said, like, we need to separate systems. Everything has to be accessible because everything has different lifetime expectations. We said we don't want to have any composites of material, just pure material so that they can also later go back, can be reused for other buildings, etc. And then this was a study we had done at my chair, like a parametric study where we looked into different geometries of a 16 square meter room, very simple, different, let's say, relationship between width and depth, different heights, different fenestration ratios, and different orientation, different glass type. So we ended up doing 3,000 simulations, and that's what I love about research. We knew the result before. But in research, first of all, you need to have a research result to prove things, otherwise nobody's believing you. But in research, you also systematically look into things. Oh, am I running out of time? No. Okay, but anyway, the result we knew before. But what we did here is basically proving Theodor Fischer right 120 years later. And it was very simple. When we have a taller space, we get, with a tall window, we get daylight deeper into the space. If we get daylight deeper into the space with the same daylight quality, we can build deeper spaces. So for the same area, we have less facade surface. If we have less facade surface, we have less heat losses in winter, we have less solar heat gains per square meter of floor area in summer. That's it. So we get better performance in winter, we get better performance in summer. And this is, we need, so this, yeah, we did 3,000 simulations. I mean, the good thing is you can automate this today. So at the end of the day, you push one button and then all the 3,000 run over the weekend. But then there was a developer, the B&O Gruppe from area close by Munich, from Bad Aibling, and they were falling in love with this research, and then they said, okay, I'm going to build you the 3 buildings. And Florian Nagler with his office were designing those 3 buildings. And what you see here, like this arch-type window in the brick building, like we were really giving this bricklayer a hard time to let's say, put this masonry arch on top of the window. But of course, we don't want to mix any material. We didn't want to have a brick, let's say, beam on top of the window where we need to have perimeter insulation and all these kind of things. Said, like, no mix of materials. And so also in the concrete building, in this insulating concrete building at the end, there is no reinforcement, no steel in this building. So therefore, again, we couldn't have a horizontal beam and have this arch-type window. But of course, we have a beam in the timber building. Simple floor plans, I don't go into the details, but what Florian Nagler always says, if we want to do simple buildings, we need to have like a simple form and simple floor plans. That's the starting point of building simple. Here you see proof of what I say, no reinforcement in this wall when we poured the concrete. But then also no floating screed. So everything was taken out what is not absolutely necessary. As a result, you get this exposed installation. I mean, you do get a different aesthetic. Not everything is super clean and slick, and you do have a cardboard on everything. It's just exposed. But if you need another wall plug, you just add it to this layer at the bottom. This is the inside of the timber building. We have a fenestration ratio of, let's say, related to the facade area of less than 20%. We have a 3.10 meter floor to ceiling height and still have very good daylight conditions. This is the masonry building and no shading. And then 2 PhD students were doing measurements over a period of more than 2 years and going also through questionnaires, surveys with the people living there. It's ordinary people, it was not pre-selected people who lived there. And like we were looking in how do they like it? and what do they appreciate and what do they hate. And I tell you, there are quite a few things they really hate. But what was interesting, Florian Nagler always says, like, so we looked into every single apartment, and it's something like 12 apartments in every building. And he said, as the architect, no single apartment has put the furniture into the apartment the way he has envisioned it. So this is people. I mean, we design buildings for people. What was interesting for us is, let's say, no air conditioning, no shading devices, no movable parts, nothing. And we achieved better than category 1 in accordance to European Code on Thermal Comfort, which was quite interesting. When we looked at energy, we do not have any performance gap in these buildings. It's actually the opposite. Except for one apartment, all the apartments used less energy than what we have predicted with the German way of, let's say, code requirement of how to predict energy consumption. So those are the 3 buildings. The question is, what does it tell us? And can we translate this? I mean, these were research buildings, these were experimental buildings, but how do we translate it to bigger scale? And this is, again, a project where we work with Transolar, with the architects Haas-Cook Zemmerich from Stuttgart. It's the headquarters of Alnatura, a supermarket chain for organic food in Germany. And they wanted to have a very sustainable building. And so Darmstadt is a pretty hot and in summer humid area. And we said, instead of using air conditioning, we use rammed earth to control climate, to provide a passive climate control in this building. And it has to be super low tech. It was very important. There was a very close connection to the CEO, to the client in this building. And the client also had the vision that all the 500 employees working in this building should work in one room. No partition walls, not for meeting rooms, not for the CEO, for nobody. And this was very important for us and very essential, because then we don't need any distribution system, any ductwork. Air can just naturally flow through the building. We do have mechanical systems. I don't want to say that we don't have mechanical systems, but it helped us to really simplify. And then Martin Rauch from Austria, he came with his machinery. He is like all the fancy rammed earth building you see in Europe. I think all of them were built by Martin Rauch. All the Herzog-Demeron buildings. So he has the monopoly on rammed earth buildings. And so he comes with his mechanics on site and has this, it's basically like a 3D printing process. And prefabs those, we put in this foam glass gravel for insulation purposes to comply with German code requirements on U value. And then he was prefabricating those wall elements and brought them with a cherry picker on site and assembled them to this building, to the superstructure. We did measurements also, we published, you see everything is open, meeting rooms are just separated with a curtain. We have operable windows, atria to distribute daylight, solar panels on this south-facing roof structure. This is how the building looks like. I mean, this is one project where we thought we can translate this idea of low-tech, let's say, on a bigger scale. Another one was this with Kartenlager Architects, this extension of the university in Witten, and it's all timber project, also mass timber. And the biggest problem we have with mass timber project, as much as we love the material, as much as we know how sustainable the material is, but in summer we do get higher indoor temperatures in timber buildings. That's the reality. And the question is, how do we deal with it? And we wanted to have super low tech. We ended up with modeling, and you see this curve which is indicating the comfort zone, and every gray dot first is indoor temperature during occupation time. And then you see the solid blue line and how much we extended. This is the overheating in a timber building. And we reach temperatures that go up to 30 and even a few hours per year up to 32 degrees, something that is certainly let's say, hard to argue. And then in the modeling, we said, like, what if we add nighttime ventilation? And what if we add a ceiling fan? Just a stupid ceiling fan, like it had been used over centuries. And, you know, nobody's using this, but in our German code, and I'm pretty sure it's all over Europe, we can reduce the perceived temperature of people in summer by 2 degrees if we can guarantee air movement. So what we call elevated airspeed, which is a ceiling fan. We can correct the indoor temperature by code by 2 degrees. As a result, we got the temperatures into the range of what's desired, and we ended up with the building just having radiators on the facade. These ceiling fans, they have a remote control. People can control the velocity as much as they like, and that's it. No mechanical ventilation, no cooling, no nothing. It's just like a reduced fenestration ratio. These white panels you see on the ceiling are just acoustical absorption, no heating and cooling. They only have radiators on the facade, that's it, and those ceiling fans. Just show this to demonstrate if we relax our comfort expectations. I mean, here I would actually increase a bit, but, but just a bit. If we relax our comfort expectations, then we can significantly reduce the complexity of mechanical systems if we follow also some basic rules in architectural design. And then just 2 projects also where we had the pleasure to consult here Peter Kutscher and Solar Lux with their buildings. This one is at the Bodensee, and it's the same ideas, the same technology. It's like you see the sky, this skylight, which is providing daylight to the center of the building, but it's also like a solar chimney that is driving natural ventilation, and in combination with the ceiling fan, that's sufficient to provide comfort for this building, for this timber building. Again, even with this knowledge that timber buildings tend to get too warm. This is sufficient to provide comfort. We do not need these complexities, these complex systems. And then here, PV in the facade, not something that, of course it looks technical, but it also has a beauty in it. I mean, we saw today a couple of beautiful buildings with PV in the facade, but there is a tendency that PV in facade makes or gives this very technical appearance and very boring appearance of buildings. We see that the opposite can be the case, but also in this building, in Kaufbauer and Solar Lux building, we use natural ventilation to provide comfort. You see the openings for the natural ventilation in combination with vegetation, providing nice microclimate for the natural ventilation. So just some elements to show you how simple things can become. And what I really like is this here, the beginning of modernism. Too bad I don't included any slides. Schools were designed, or all buildings were designed like in the 20s of the 20th century. All buildings were designed and was always about the interaction between inside and outside. It was always about how do we open buildings, how do we get people exposed to an outdoor environment. And then again, because of the invention of air conditioning, the opposite started to happen. We start to hermetically seal our buildings and control our indoor environment, and the engineer make people believe that this is something we have to do to save energy. And the architects also contribute to the problem, I have to say, sorry. Yeah. This is where we are and what we have to rethink, and this is like those buildings, like the Open Luft School of Ben Dijkers in Amsterdam, built in the 20s, where students were sitting outside. And the interesting thing is, with the moment when we sealed our buildings and put people into controlled environments, the percentage of people with allergies was going up, till today. It was almost zero in the 50s. Today, in the Western world, we reach something like 40% of the population complaining about allergies. So I wonder if we can really maintain this idea that sealed buildings are more healthy. Anyway, let me conclude. What are the potential role models of the future? This is something where we can also put a question mark on it. Can we really translate it? We tried to translate it into, or to use the principles for an apartment building in Munich, but we failed with the 3-meter plus floor to ceiling height because we would lose a floor in the city with the highest property expenses in Germany. Did not work. So something we have to question. Then Florian Nagler, his timber building, we saw the mechanical system, but we also see the problems of overheating with timber. And timber is a fantastic material, but maybe it's not the best material for every type of building. And maybe it's not the best type of material for every single, let's say, building component. I think we need to use mineral materials also in the future. And the question is, like the rammed earth building we showed you, the Alnatura, the question is, how do we mix it with timber? How do we mix timber structure with mineral materials in a smart way? I think this is the future. Here, rammed earth, I mean, it's handmade still. And I said, Martin Rauch has the monopoly on those type of buildings, and he can't build every building in Europe or in the world. So if we really want to make rammed earth, or let's say clay, because it's not about rammed earth, it's about clay. If we really want to make clay a successful building material that we can scale, we have to bring it into an industrialized process. We have to get out of the niche. Reuse of material, didn't talk about, very important topic, circularity. But this is a project by NC2 where they used 95% reused material in Zurich. Great project, great ideas, and I really support the idea of reclaiming material. However, a study in Germany shows that if we use everything out of demolished buildings, all material that comes out of the demolished buildings, the maximum we can cover is 10% of our needs. So we should just not make people believe that this is the answer for all the problems in the world. It's one contribution, not more. I jump over this, but then I have to show this. I love this WOHA building, and we were once going there for doing microclimate studies in Singapore with students, climate walks, and one of our PhD students, Atta Chokachian, he took this infrared image. And you see how well from this WOHA Royal Hotel, how well the temperature is reduced where we have the vegetation. But you can also see to what extent those glass buildings reflect heat into the public realm. Basically, yeah, I have to say, they ruin the effect of the vegetation. And if we go through the numbers, a square meter of highly reflective glass facade, 2 square meters of highly reflective glass facade would need the projected surface of 1 square meter of tree canopy in public realm. If we want to compensate the heat that comes from this building with trees in the public realm per 2 square meter of this highly reflective glass facade, we would need 1 square meter of tree canopy. So we would need a forest of the heat that comes from this building. And that's the other complaint we have about facade engineering. Through the last decades, we were optimizing facade engineering with metrics over and over. It became over and over complicated, but we consider only the implication a facade has to the indoor environment and to the indoor performance. We never look at the implication a facade has to the outdoor environment and to people. And so if we really want to take this question of greening and controlling microclimate in our cities with green and blue infrastructure, we also need to control the facade design with regard to its implication to the outdoor environment. This is a project we did with TVK Architects and Transolar in Paris, where we got involved in the remodeling of Place de la République. And it was all about how can we improve microclimate Place de la République. But the question also is here, Place de la République is amazing, but it's not going to solve the microclimate problems of Paris. I mean, that's something we need to be aware of. We need to be, if we really want to have an impact, we need to be much more radical. Let me jump over this. Let me finish with this rethinking of thermal comfort, something I started with air conditioning. We started some research about thermal comfort with the hypothesis that discomfort might actually be healthy. So we called it healthy discomfort. So is there really a correlation between comfort and health? Is it really healthy for people? I mean, your seats are pretty discomfortable. But it makes sure nobody's falling asleep. So there is a benefit here. So the question is comfort and health really the same thing? And what we always use as a metaphor is that we say, we know that taking the elevator is more comfortable, but we know also taking the stairs is healthy. So maybe there is no correlation. And as more we're digging into this, as more proof, let's say, as more indication we found that the hypothesis is actually right. There are so many studies worldwide that were looking into discomfort. And like, for instance, in Belgium, they had something like 15 or so test subjects, all of them slightly overweighted, all of them with the risk of getting, how do you say? Zucker. What is Zucker? Diabetes. Yes, thank you. All of them, let's say, being with the risk of getting diabetes, and they exposed them to 35 degrees, 8 hours a day, and they needed to work over weeks on 35 degrees, 8 hours per day, and most of them, the risk of diabetes decreased. In the university in Montreal, they measure people, or the health of people when they are exposed to cold. Same thing, they found clear indication that it's good for the body. If we get into discomfort, I mean, the question is always how much and for how long. But when the body is getting into discomfort, it's basically nothing different than doing sports. If you do sports, you bring your body into discomfort. So it's indeed comparable, and the hypothesis is it's actually healthy, and it's increasing alertness and making spaces also more interesting if we can have a variation of comfort and discomfort. So we have this sense lab where we put test subjects, we call it. At the end of the day, it's always students. Sorry. And we use biosignals. So we have wristbands that measure the heartbeat rate, that measure the electrical conductivity of the skin, so that we can really see when people get into heat stress. And we let them work for 8 hours a day, 4 hours in the morning, having a lunch break, and then 4 hours in the afternoon. This is how it looks like, and we can provide all conditions we want. Here again, a picture from the inside. And like, this was the first result. So what we found in the first result is actually indeed 27, which is the threshold we have by code in hot cities in Germany, not 26, 27. With 27s, we do not, on the left side, you see electrical conductivity of the skin, which is an indicator for heat stress. You see that 27 is still quite okay, but then with 28, heat stress goes up exponentially. So when you see this result, you would say, Fanger, code, everybody is right, okay, check. But then we looked into how it evolves over the course of the day, and we found that there is a big difference between morning and afternoon. We had people exposed to 30 degrees, and we did not see any heat stress in the morning. But we always saw heat stress in the afternoon, and then we were digging through literature, and it has to do, of course, with, like, say, burning food, burning lunch, but it also has to do with the circadian body temperature. Our body and we all know this, when we have fever, we measure the highest temperature early evening, late afternoon. That's the time when we have the highest body temperature. And that's the time when we find heat stress also in buildings. So we said, we could solve this problem with very simple means. Maybe people are not designed for working 8 hours a day. That would be the easy solution. But maybe also siesta was not a bad idea. So maybe we need a longer lunch break for resetting the body to solve this issue. And then Sebastian Koth and Bilge Kovacs, they were driving this research, and Basti now used this idea of this dynamic comfort in his thesis and proved that there is indeed big potential when we provide air conditioning only parts of the day after lunch. Now let me finish with this quote from Daniel Barber. He wrote this very essential essay he called After Comfort, where he said, comfort like capital is unevenly distributed. I mean, this is something that we need to be aware about. We take comfort for granted. It's the minority of the people in this world who has access to comfort. People in India, when they had a heat wave last year with temperatures above 50 degrees, people died. So we provide comfort for those who can afford it, not for those who are in need. I mean, that's something we need to be aware of. And then he said, however, it's in short supply in face of climate crisis, etc. We collectively have to adjust, it's going away. And then he said, architects are on the front lines, finally the avant-garde, building a world at the edge of discomfort. And that's something we found, that was intriguing for us, the idea that we design towards the edge of discomfort. Over decades, we were talking about maximizing comfort. What is this? I mean, in the US, they try it by not only in the US, also in Singapore, by overcooling spaces, and most people complain it's too cold. I mean, how stupid is this that we waste energy and do not even provide comfort? And we know that people experience comfort differently. We know there's a difference by sex, which is scientifically proven. We know that women perceive thermal comfort differently. And we have a man in a suit with a tie-driven indoor climate in the world. And we just take it for granted and waste energy. And I just learned that sociologists, they call it the escalation of consumption. We design buildings for an escalation of consumption. I really thought I need to remember this term because it's so absolutely right. So with this, I want to close this. Thank you very much.
Thank you so much. Now I invite everyone to a coffee break.